So AJ, thanks for joining us here today.
Thank you for having me.
So what brought you to Beyond Limits? Can you tell us a little bit about yourself and your background?
So July 20th, this July 20th, we're going to celebrate one of the greatest achievements of the human race, and that's the human landing on the moon. I still vividly remember 50 years ago watching as a little kid with my parents on a black and white TV, Neil Armstrong taking that first step on the moon. I was at awe, I was amazed, impressed, and inspired to become an engineer. You know, I wanted to really get involved in solving technical problems. And little did I know that decades later, I would get the opportunity to collaborate with some of the brilliant minds behind the space program, and then lead an AI engineering company coming out of that space program. I think that's cool.
Yeah. Yeah, so AJ, so you're referring to the Jet Propulsion Lab in Southern California, NASA's lab that was responsible for the exploration components of space, you know, initially on the moon and now Mars. Talk about some of the problems that they were facing and why that's relevant for today, right, in terms of AI and machine learning.
So NASA has 10 major centers. JPL is one of them. It's based in Pasadena. And their mandate is to focus on the unmanned space program. So all the robotic missions they send to explore our solar system and beyond, the rovers they land on Mars, are managed by JPL. Mm-hmm. And when you're operating in space, you're operating in a very harsh and dynamic environment. You know, you don't have access to the computing power. You don't have access to Amazon's, Microsoft, Google's amazing cloud. You know, you're going to have gaps in the communication. You're going to have issues with the data, and by definition, NASA's mission is to discover the unknown. So if you're really trying to look for something you haven't seen before, you can't train your data set on that. So JPL, as a result, they created a world-class organization to focus on how can we mimic human-like reasoning to allow these missions to survive on their own. The journey to Mars takes it's 150 million miles. It takes 6 months to get there. The signal takes 15 minutes to come back to Earth. So it's difficult to operate them remotely. You have to extend that human intuition to these robotic missions. Right. And that's what they've been focusing on for a couple of decades. They created a phenomenal capability. And we've been fortunate to license those capabilities and technologies. And now we're trying to bring them here to Earth to solve some very complex technical problems.
Great. So that sounds super cool, right? So as you say, now we're coming back to Earth where there is the cloud, right? So right. Those were all solutions created for space where the cloud doesn't exist. But you do have the cloud here. So why do you need this cognitive approach? And we'd like to start getting into what is cognitive AI. Maybe you can talk about what it is and why we need it.
Sure. Well, you don't always have access to the cloud here on Earth. I mean, for example, one sector that we are working closely with is the energy sector. You know, they actually have a very similar environment like space. They operate in a very harsh environment, whether it's the Arctic Sea, you know, underwater, the Gulf of Mexico, the Sub-Sahara. So you have similar environments here on Earth where you're not going to have access to the cloud. But to answer your question is the approach, we're borrowing a page out of what JPL is doing to solve these complex problems in space. They have deployed it in space, in defense application, and commercial applications. They do what we call a full stack AI engineering, which is a unified approach. Will take the numeric side, well represented by machine learning and deep learning. When you have the data is important and relevant. Yeah. Okay, but also you have the symbolic side. You know, we still believe here at Beyond Limits that human knowledge, human experiences, human wisdom is really relevant, and infusing both is very powerful.
Yeah. So, and you've got some massive clients in BP, right? One of the largest oil producers, Exxon, and you mentioned Mitsubishi. Some of these massive industrial players that have so many of these things going on without cloud. As I understand it, you've essentially, if you boil it down, and correct me if I'm wrong, but you're accommodating machine learning and AI in whatever practice and implementation is necessary. Then you have this cognitive layer on top. It's essentially rules-based, but making sure that the human mind is deciding how all these things are put together. And then there's three other elements. You have an audit trail, right? And then you also have ability to sense with IoT on the edge, right? And then to continue if there's no human authority there, right? According to the rules engine. Could you talk a little bit about, and I think we have a demo, but maybe can we set this up as Kristen gets ready on the demo? What are we going to see? And how, maybe I think it's a refinery example.
Correct.
In terms of the cognitive AI approach here.
Just a quick comment. So the symbolic side is not only rules-based, that was kind of like the old, your grandfather, symbolic AI. It's also physics-based model, pieces of wisdom, advanced case-based reasoning, all of that. So some class of problem cannot be solved with data alone, with machine learning and deep learning. What we're going to show you here is an example where we're looking at a refinery. Today, the state-of-the-art AI solution for those kind of environments is to basically, the refineries are, by the way, are heavily censored. You have sensor on every device. So state-of-the-art is today predicting whether a device is going to fail, a tower is going to go down. We do all of that, and that's wonderful, and you need to do that. But you also need to have a layer on top of that, which no one has attempted. We were the first to basically attempt that. Now we can align with the person managing that refinery, so we can align with their objectives, so they can build a system of systems that can oversee everything that is going on. And you're going to see from the demo the kind of capabilities we have built.
Yeah, and this, just before we get to the demo, because I think this was important, is that you're one of the first companies I've heard of that is claiming to have this systematic approach, right, or systemic approach to AI, where you're accommodating all those layers, right? All these things we've been hearing, bringing it all together. And British BP, with the Deepwater oil spill, $70 billion in cost. They've got to get this right. Right, so they've invested $20 million in
They actually invested $45 million so far.
$45 million.
Yeah, I mean, the company was launched in 2014. If you asked me in 2014, would energy be my biggest vertical, I would have laughed, But we ran into BP in kind of 2015, and I really am a big fan of BP because after the Deepwater Horizon, the situation you just mentioned, they went on a search for the right AI approach and the right AI partner. And they went through some major players. And it became very clear to them that machine learning and deep learning is just one part of the equation. Yeah. They really need to do something a lot bigger. Right. They need that cognitive reasoning approach that we're taking from JPL. So when they heard the story, they loved it. They made us jump through hoops, by the way. Right. We had to prove it to them. And they gave us some tough use case scenarios.
And they approached, that's what I've heard, they approached IBM,
Palantir,
GE, all of it didn't work, then they came to you. Could you talk a little bit about that process? You've got the whole project? Or?
Well, so as I mentioned to you, with these players, they have wonderful machine learning and deep learning solutions, but clearly it was not what they were looking for. They were looking for that cognitive reasoning approach, that unified approach that would utilize the machine learning side, the numeric side, and also the symbolic side.
Yeah, great. Okay, so let's get to the demo. Maybe we can see how this works.
Kristen?
All right, so thank you, AJ. My name is Kristen Lennox. I'm the technical head for industrial IoT at Beyond Limits. And what you are looking at on the screen is a small segment of an oil refinery. It's 3 distillation towers. And over the next 3 minutes, we are going to fast forward through a month in its life. And so we have something that we call the Refinery Operations Advisor, which is being applied to this particular system. When some things are purple, they're all good. When things are red, there's a problem that we're trying to solve. I'll go into details for that. And when things are yellow, we have a different kind of problem to solve, which I'll touch on at the end of the demonstration. So a refinery is an extraordinarily challenging facility to operate. It's challenging because they're very complex. So imagine a chemistry set that's the size of multiple football fields, and it is processing millions of gallons of material every day. When you make a change in one portion of the refinery, whether you like it or not, you're going to change things throughout the system. You can't ever hit pause to try and figure out what's going on because the flow is ongoing whether you like it or not. They're extraordinarily challenging because the stakes are high. If you make a bad decision, there are potentially dire consequences in terms of health, safety, environmental situations. And so you want to make sure that you're making the best possible decisions all the time. And finally, they're very, very challenging because the way that we run oil refineries today is different from how it's been done in the past. And by the past, I mean potentially last week. So there are changing regulatory conditions. There's aging equipment whose behavior is changing. They're trying to maximize economic benefit based on current conditions in the market. So the way that you're operating this kind of enormously complex facility today may be different than anything it's ever done before. Your previous experience and your past data isn't necessarily going to apply to what you're doing right now. So how can a cognitive AI system support people in this kind of environment? Well, we ingest all of the data from the sensors monitoring the current state so that we can get as global a picture as we can of what's happening right now in the facility. We then have a machine learning layer that's sitting on top of that, trying to detect situations that are of interest right now or when we're maybe trending in an undesirable direction. And then sitting on top of both of those, we have the cognitive AI layer. And what that includes is the current goals for the refinery, the best practices for operating it, variety of solutions based on engineering knowledge for how you would resolve particular situations, so that when we see an undesirable situation, such as this one here, we can do a global search throughout the facility to try and find a resolution. And we can report what is the problem that we're seeing and what do we think we should do to solve it. So far, that's pretty standard. Lots of automated controllers do that. We're going to also give you the full reasoning trace, all of the data, all of the steps that were used to arrive at a particular conclusion, which is really important when you're thinking about a situation when you can't entirely trust your data. You can't entirely trust your previous experience, so you do want to be able to go through and validate the decisions that the situation, that the agent is coming up with for you. And so that brings us back to the yellow sensor situations. There are other ways that you can try to run a refinery according to a plan, maybe not as good globally, maybe not as transparent, but there are things that you can do. But what do you do when the plan itself is the problem? And this is going to happen pretty frequently. The plan is based on previous experience. It may not apply. It's based on simulation models that may not be calibrated properly. It may be a situation where the weather isn't what you were expecting, so things aren't behaving the way you thought they would. So in addition to constantly evaluating the operations and trying to figure out how do we make those as good as they can be, we are simultaneously evaluating the plan. We're looking for situations where we are not achieving the objectives that we thought we could because the plan itself is the problem. And then we're reporting back to the engineers, what are the situations that are driving this? What are the linked environmental variables? And how can we change the way that we're thinking about our refinery so that it's closer to what we're actually seeing on the ground at a given time? So this is not just a problem with oil refineries. There are lots of different industries that see this kind of situation. Chemical processing, pharmaceutical manufacturing, food manufacturing. And what we are trying to do with cognitive advisors is make the computer a transparent partner to the human, something that they can work with to extend their vision, to extend their reach, and to help them take their particular industry beyond its current limits.
Great. Thank you, Kristen, very much.
Kristen.
Right. Yeah, it's hard to demo such a sophisticated project, obviously, but you tried over 3 minutes. It was hard to read some of the, for example, the audit trail details, but conceptually, you got across most of the main points of this integrated system. Two things I didn't see explicitly mentioned by her, maybe alluded to, right? Edge awareness when there is no information. And I guess it's linked with autonomy, right? Which are some of the key components you had coming out of the, I believe it was the rover background that you had, right? Where the rover didn't have any communication for, what was it, a couple of days or a few hours? And then was able to actually overcome some of the problems because it just followed that cognitive layer of the rules that it's supposed to follow. But can you talk a little bit about those other two components? Were they present in this case, or are they present in other cases that you're?
So in this case, the really important thing to kind of focus on that the data, the previous data or historical data is not going to be relevant because this is a very dynamic environment. You're dealing with a dynamic situation where the configuration, things are going to change, you know. Machine learning is going to be important, but you need that expertise and wisdom from the human side and from the human element to really basically adjust for that. Allow the system to basically leverage that expertise with machine learning and make the best decisions possible. And what we like about this, you know, as Kristen mentioned, this is not just, this is for continuous process engineering. You know, this can be applied into factories, pharmaceutical, chemical, and food processing.
Okay.
You brought another excellent point, which is edge computing, you know, and robotics and autonomy. A lot of people tend to confuse automation with autonomy. They're really two different things, you know. With autonomy, you really need to build that intelligence to allow these robots to make human-like decisions and human-like intuition to allow them to basically achieve their objectives. We trust the Mars rover to basically make decisions and empower these spacecraft to say, you know what, I may see something different than what I was programmed to do. This sounds really relevant in my mandate to discover the unknown. You know what, I'm going to override what I was told to do. I'm going to basically look at this interesting phenomenon.
Yep. So I was told that you had, because of the BP relationship and the investment, they had asked for an exclusivity for 17 and part of 18. So you're free in 19 now. You're looking for other clients, and it sounds like you told me you might have an announcement today.
Yeah, today we're excited to announce we're going to announce a strategic partnership with Excel, a Swiss-based company, to build the first AI cognitive power plant. This will be the first implementation of an AI cognitive power plant that would be built from the ground up. Okay, where we're embedding intelligence and operation into its entire operations. This is going to make the plant safer. It's going to maximize efficiency and productivity, and it will make the environmental situation more friendly. We're excited about it.
Yeah. Is there a dollar amount that you're attaching?
So the initial phase 1, phase 2 is going to be about $25 million, but we see a significant growth in this industry, and we're very excited about it.
Yeah, that's great. Congratulations. So I wanted to make sure yeah, great. Good.
Thank you.
Great traction for such an early company. And again, I think it exhibits the demand for these sorts of solutions. So it'll be interesting to follow how far down from the industrial layer you could possibly go.
Let me just add, the exclusivity with BP ended in 2017. I'm happy to talk to anybody.
Okay, all right, great. So he is welcoming conversations. But questions on this cognitive approach, right? Because the claim from Beyond Limits is quite bold, right? That they have integrated all of these elements in ways that no one else has. I see a question up here. So you mentioned, yeah, I'm going to take this question here. I was going to go on to the next question, but here it is.
I'm very curious about the human element in your experience with BP. I work in the oil industry. I actually built control systems for refineries a long time ago. But one of the challenges at that time was dealing with the people actually on the ground and acceptance of what we were building supervisory control systems the old-fashioned way. acceptance of recommendations from a machine, from operators or engineers in the actual plants, and how was that interaction at that time? Just curious to see how you handle that, or your people handle that.
Great question. That is really the biggest challenge. I can tell you as the CEO of an AI company, for AI to succeed, it really has to be endorsed and embraced by the executive management. If you don't have that endorsement or acceptance, it's not going to work. We've been very fortunate that at BP, they made the decision, you know. I mean, Deepwater Horizon, Matt mentioned, $70 billion. That's a very costly situation. So there was a strong commitment from the top. The other thing I would like to add, we at Beyond Limits, we really truly believe in this whole collaboration between human and machine. You know, machine is going to play a very important part, but we want to magnify and amplify the human talent. We're not here to replace humans. In fact, we think we can extend that capability. I think what we did at BP, we start having these conversations, and once people start, you know, looking at, you know, this is not going to replace me, but I can actually use this tool to be more productive, we're finding that a lot of people are embracing it right now.
There's a question here in the front.
Were there specific types of training programs that you put in place to get the executives comfortable with those recommendations? And not just at the exec level, but down to the operational level? What kinds of literacy or training programs did you put into place?
Again, as I mentioned to you, they made us jump through hoops. So I guess having a successful implementation on Mars was not good enough. They gave us a couple of tough use case scenarios. It was not based on live data or real time in real time environment. So the phase 1 implementation was based on historical data where they could validate the accuracy of the system. You're shaking your head. I'm just curious. All right, right. No, I agree with you. I mean, this is where for people to accept, for the guy at the well to accept that, okay, you're giving me now a tool that I'm going to use. Ultimately, by the way, the decision is going to be with that human at the well. This is a tool that's going to basically help him support that. But even to get to that point, to let him accept that this is going to help him make that the right decision, is we had to go through this process where we can prove some previous examples before. The other thing I would like to add, and I think Matt mentioned on that before, the ability, the explainability element, and also the track, the audit trail is very important, because now you can go back and point to one assumption, one point, and say, you know what, I'm questioning this. The system is dynamically going to configure that. It's going to basically store the previous data, but there is also an accountability, an audit trail there to basically make sure that whatever decision was taking place, that we have an audit trail for it.
Great. I think we do have time for one more question or two quick questions. Anyone else? So I was going to go to Mike.
If I may, Matt, I listened to the previous talk.
Absolutely. Yeah.
And one question was about training and how non-technical AI people can get involved. I'd like to just add, we take a different approach in terms of deploying our AI solutions. So most Silicon Valley-based companies, they tend to go after like computer scientists and data scientists. And by the way, we love them. We use them. There are plenty of them at Beyond Limits. Yeah. But the approach we take at Beyond Limits is, we borrowed another page from NASA's JPL, is we start with domain experts, you know, the petroleum engineers, the petrophysicists, the geologists. We found out that it is very efficient to take a domain expert and basically teach him the AI tools and capabilities, rather than basically take a pure computer scientist and teach him the domain expertise. I think this is going to open the door for where the human expertise, knowledge, creativity is going to play a significant part.
Okay, great. Round of applause for AJ. We're out of time.
Thank you.
Yep.